Dektak 3, Veeco Dektak 3 surface profiler will be shipped with the sample holder out from the profiler, and the system will be shipped out with a HP 1600 printer. It's a test jet printer, and this profiler actually profiles a 3D surface as a two-dimensional profile as shown in the red ink here. And in order to do that, the stage slides out. The stage actually moves on the glass surface here, and the stylus tip here which touches the surface of the sample just grazes over the surface. So the system is very sensitive to the ambient turbulences of air, so care should be taken to avoid any fans in the vicinity. So in order to load the stage, you need a slotted screwdriver, and there is a screw here, and use it to rotate it clockwise, and then under the stage there is a geared beam here. It should go through this opening in the column here, and then make sure the stage sits on the glass, and then rotate the slotted screw counterclockwise so that it gets latched. On the profiler there is a camera and a light source on the left hand side, and the light intensity is adjustable by the knob potentiometer here. The lamp source gets the power from the PC, and also the camera also gets the same DC power. There's a 37-pin connector here that goes from the profiler to the PC. All the cables and connectors will be marked, and there is a add-on board inside the PC which is in an ISA slot, and the cable, 37-pin connector cable, goes to that board. Also, the DC supply to the camera and the lamp comes from this connector from the same board. So I connected a LPT line printer parallel printer here. The keyboard and mouse are also connected. The system is booting up. As the system boots up and it enters into the Dektak profiler screen at the end of the boot up, no changes to the PC should be made. Attempting to connect a USB mouse or any other USB device may ruin the integrity of the PC. It's advised not to connect anything to the USB port. The PC comes with a floppy disk drive and a CD-ROM drive, which are enabled and are tested working. The system works with only Windows 98 operating system, and the BIOS parameters are adjusted in order for the system to work for the profiler properly using the ISA slot in the motherboard. So In this first screen, there is no network password available, so just cancel it. In the video overlay program, the video source should be always selected as NTSC composite signal if necessary. If by mistake, if anybody has changed it, it will cause problem for the video display of the surface profiler. Soon after loading the software, the system will initialize the stage. First, go to the video only display, and then we can see the patterns on the waveform. I have a standard here which is about 9,000 angstroms. So the display mode can be changed to video only or graphics only, or both video and graphics. And the stylus can be brought down using the menu item here. Stylus down. And the stylus will come down and touch the sample, and the image of the stylus usually has to be aligned to be at the center of the crosshair. By moving up and down the camera arm, we can change the video image with respect to the crosshair. So by going into the setup and selecting stylus reticle, and then in align mode, we can align the stylus. I'm in the align mode. So in this alignment procedure, you have to press the crosshair image here exactly where the stylus tip touches the surface, and double click the left button on the mouse. And do you wish to update the stylus reticle location? If you say yes, the reticle is now aligned with respect to the surface where the stylus will touch. Then position the crosshair, the cursor here at the intersection of the image and say yes. So now the stylus is aligned. Once it is aligned, it need not be aligned unless the camera is realigned at any point of time, or sometimes if the substrate thickness changes, at that point you may have to realign it. In the menu items, there is a possibility to run in a multi-scan program mode or a scan routine mode. In a scan routine, you enter the scan parameters such as the scan length, speed, number of data points, and then the type of profile. There are three options available: a step up and a step down, or both step up and down. And all these numbers can be changed if necessary. And there are three speed modes available. Low speed is a 50-second scan, and the medium is 25 seconds, and the high speed is 10 seconds. The horizontal resolution is high with low speed and low with high speed. Also, a user's manual will be included with the system, which explains all the available information about the system. So to run a single scan, you can go to the Run menu item and click on this. And in the setup, we have vertical calibration at the time when it is desired to calibrate the system. We can use the vertical calibration, and then stylus reticle alignment here, and then assign printer. This system can be assigned with two kinds of printers. An original OmniPrint 426, which is called an internal printer, but this machine is shipped with an external printer option. Also, there are other setup parameters available, such as working directories can be assigned, and assign analytical functions to keystrokes is also possible. And in diagnostics mode, there are 4 items available. So these are diagnostics mode is only for the service engineers who wants to test the machine at the time if any error messages are seen. I'm going to run a profile scan. The system should be warmed up for about 20 minutes to half an hour before actually using it for profiling. Also, care should be taken to avoid touching the profiler or the table on which the profiler is placed at the time of profiling. So it is always safe to isolate the computer and printer from the profiler table, just like I did here. Now this is after the scan, the profiler also leveled the profile. Now in order to measure the surface height, move the measurement cursor to the profiling area and reference cursor close to it. Now the difference here, or you can see on where the measurement cursor is, the vertical distance is 9,476 angstroms. So that is the step height. So we can also use the built-in analytical functions to measure various parameters such as roughness, average step height, and then peaks, valleys, and average height, and we can compute it. So now we can see the average step height using these cursors of about 20 microns each. The average step height is measured as 9,423 angstroms. Okay, this is another run with a different sample, and this sample is approximately 50,000 angstroms. These standards are in-house standards and will not be included with the machine. So as the surface scanner is profiling, there is a procedure in the manual explained. Using the big dial knob in front of the stage, the leveling can be achieved in order to get a very horizontal or a close to horizontal line profile like this. So I'm going to position the measure and reference cursors. So the average step height here is about 49,000 angstroms, or 4.9 into 10 raised to the power 4 angstroms. The full scale division is 50 kilo angstroms, and the profile, the peak point is close to 49. So in this system, in this routine, I have the reference cursor at 100 microns and the measurement cursor at 1900 microns, and I have a band of cursors 20 microns each, and I have selected the system to display the auto range, and it will also level the profile soon after the first scan. I'm going to change the sample to another one, which is about 1000 angstroms, and demonstrate that the system is able to profile that. I'm just repositioning the stylus. So there are two knobs on the stage. One for the image moves vertically up and down, but the stage table moves left to right. The other knob, the stage moves back and forth, and the image moves left to right. After the tower goes down, there will be a wait time till the scanning begins, and once the scanning begins, we can see a white dot cursor moving on the sample screen, and the sample also is moving. We can see that. So we can notice that this is a almost 1000 angstrom step height, and you can notice this pattern here, which shows I did touch the profile while it was in the middle of profile. So I'm going to run it again and show that. So this is a better profile than the previous one, and yet we can see the slight vibrations, and this is a resolution of the order of angstroms. So we can replot the cursor by just changing the level and zeroing it. And there's also cutoff filters available to smoothen the profile if necessary. I'm going to print this plot and summary. For the shipping purpose, the sample holder stage will be removed from the profiler, and the stylus tip will be locked in position using a shipping bracket. And at the time of power up the system, the bracket should be removed from the head. For the safety of the system, the camera arm also will be removed from the stage. These 3 Allen screws, by removing this, the whole arm can be disconnected, and once the stylus profiler is on a table, it can be reattached.